Hi folks. I forgot to say something in the previous video, so let's get that in this video here. We're doing polyatomic ion compounds, and one of the things that you will be doing with them is translating from names to formulas and formulas to names. Okay, luckily you have everything that you need, and that previous video that's all about charge and creating neutral charge so that you have the same amount of positive charge as you have of negative charge. That is the key to everything, including all of this stuff. So off we go. So these are polyatomic ions. Polyatomic ion compounds. And that is super zoomed in. This is going to have some lag, and I'm not totally sure why, but we'll go with it. Okay. Polyatomic ion compounds, and here we're looking at names and formulas. So you're going to have questions that say, here's the formula, write the name, and you're going to have other questions that say, here's the name, write the formula. Okay. So let's do something that we didn't do in the previous video. Let's do, we're going to start here. Okay, so first things first, is that a name or is that a compound, a formula? Since it doesn't have words, it's not a name. That's a formula that's got the symbols instead of the names of the things. So here I'm giving you a formula, and I want you to write the name. Here's the formula. And you're going to write the name. Okay. We'll do this first one in a lot of detail, and then we'll do some kind of faster. You probably remember from last quarter that capital letters indicate a new element. So here we've got a capital M with a little g and a capital C and a capital O. So these are three different types of atoms here. We've got magnesium. Oops. Gave you that. We've got Mg. One capital, one lowercase. That's a single atom. Look that up over here. Yeah, your Mg is magnesium. And then we've got a capital C, carbon. And you may already notice a capital O is oxygen with all your polyatomic stuff. You may already kind of recognize that there's a polyatomic in here. Another way that you could do this is you're saying there are three different types of atoms here. I know it's a polyatomic ion compound. Two of these are in a polyatomic. You've got a cation and an anion. All ionic compounds have a cation and an anion. So one of the first things that you do is you look at this and you say, what is my cation? What is my anion? And here's your clue. Metals are almost always monatomic cations. You're going to say, hey, there's some metals that are in polyatomic ions. That's true. So usually, metals are usually cations. Not always. I've got this one here that's got a metal and is an anide, but the metal is surrounded by the oxygen. You may have noticed at some point that most of your polyatomics are something surrounded by oxygen. Something surrounded by oxygen. You can have a metal, kind of as the diva in the middle, surrounded by oxygen. The oxygens hold extra negatives. Don't worry if that, it's totally fine. But kind of like breaking it down one more level, it's all these oxygens that hang out around the middle atom that hold on to the extra negative charges. So if you've got a metal surrounded by oxygen, that can also sometimes hold some negative charge. But in general, metals are usually cations, usually the positive charged thing. Positive charge. Okay. So here, with your magnesium, carbon, and oxygen, you look those up on your table, your periodic table. You did some trend stuff last quarter, and we're not even going to go deep on the trend stuff. We're just going to say your magnesium's over here, carbon's over here, your oxygen's over there. These are metals. These are nonmetals. And that's kind of going to be your clue that this metal is the cation. And your nonmetals, like carbon and oxygen, is your anion. Nonmetals are usually anions. Nonmetals are usually anions, and often the nonmetals are things in the polyatomic. It can be a little bit, just this first step of like breaking your formula into the cation and the anion. If you've got a metal in front, just break it right there. So magnesium is your metal, usually cation, and your carbon and oxygen are two nonmetals hanging out together. And you know it's polyatomic. You can look around and say, is there a polyatomic that is CO3? And if so, what's its charge? And okay, oh boy. If you make yourself a cheat sheet of these, which you totally can, these things that end in 8 are the ones you're going to see a lot of. And there's your carbonate. So your CO3 is CO3 2- is a carbonate. Your magnesium, just do a little check. You know that charge is important. Here's your magnesium. It's in that second column. Everything, all the alkaline earths, everything in the second column is a charge 2+. So you've got a magnesium 2+ and a carbonate 2-. That's neutral. 2+, 2-, neutral compound. And the name is the name of this, and then the name of that. That Mg is magnesium. And that CO3 2- has the name of the carbonate. So if you're given a formula and you want to write the name, it's kind of just that. The tricky part is figuring out what is the cation and what is the anion. Cation's always first, just like last quarter. And once you find it, write its name. Anion's always second, just like last quarter. Once you find your anion, write its name. We can do another formula to name. Let's do... Oh, I'll do one that looks messier, because why not? Oh, this one's going to look pretty messy. Okay. But even already, even though I'm telling you that this is a messy one, you probably know the first word of its name already. This is aluminum something. Okay. Wait, hold on. Oh gosh, I haven't done this in so long. Yeah. Okay. So that's something. And this one looks messier, right? Like it's got parentheses, it's got 3 subscripts. Oh my gosh. Okay. So here you're saying that there's 2 aluminums and there's 3 of whatever this is. And formulas to names is kind of nice because you actually don't have to worry about the math. I'll show you anyways because I want to give you a little bit more practice with it. But to write, here's the formula. To write the name, off we go. You recognize, it's possible you recognized Al right off the bat as aluminum. And then the only thing you have left to do is figure out what that is. And I just realized that when I give you the parentheses, it's actually in some ways easier because you can think of these parentheses as being that polyatomic. So now you know you're looking for something on the circle side, on the polyatomic side, that has an SO4. Okay. And you already even know it's an SO4, so it's got the S in the middle. So find your stuff with the S in the middle. Here's an S, there's an S, there's an S, there's an... Okay, so you're looking for an S in the middle with 4 O's around it. And there you go. There's your S in the middle, 4 O's, because your formula was SO4. 1 sulfur, 4 oxygens. And there's its name. And its formula. And its charge. Very okay. S in the middle, 4 oxygens. That is a sulfate. It's got the formula SO4, 2-. Alright, take that with you as you go back over here. So that is a sulfate. And that is the name. And let's do the charge math just because this formula looks so funky. We might as well. Okay, so we figured out that an SO4 had the charge of 2-. Okay, so your sulfate, your SO4, has a charge of 2-. And your Al has a charge of, so that's just an aluminum. That is a single atom ion, a monatomic ion. Aluminum has the charge, right there. Okay. Oh boy. Charges of ions. Everything in this column is +1. Everything in this column is +2. You drift across the land of the unknown. It's possible that I have no idea how much depth you went into. These are the transition metals. They have variable charges. And because we don't know what their charge is, we write it as Roman numerals. So I'll do an example with a Roman numeral also here in just a second. But here's your ocean of transition metals. Ah, that's cool. I'll tell you why that's cool later. Okay, ocean of transition metals, and here's your aluminum. We're trying to find the charge of the aluminum. +1, +2, skip across the sea. There's the aluminum. plus 3. Everything in this column is plus 3. All right, so your aluminum is plus 3. And again, this is bonus. You don't even need this. You already wrote the name right there. I'm just showing you this because charges are the key to everything. But when you do these, you actually don't need to worry about the charge. If what you were doing is writing the name, you're already done writing the name. Check, dang, okay. But just to show it, your aluminum has 3 positive charge. Your sulfate has 2 negative charge. Not balanced. We need more negative, add another sulfate. Plus 3 minus 4, still not balanced. Now we need more positive, add another aluminum. Now we've got plus 6 minus 4. Nope, not neutral, not 0. Add another negative. Plus 6 minus 6. That's a neutral compound. Now your plus charge and your minus charge neutralize each other. Equals 0. Net charge is 0. Okay, so we have 2 aluminums that are plus 3. That's where this 2 comes from. We have 2 aluminums that are each plus 3. And here are your sulfates. Here we've got 3 sulfates that are each minus 2. And it works. So this compound, this formula is correct. And it has a name of aluminum sulfate. Okay. I'm going to do one more with a transition metal so that you can practice with, so that we can practice with, well, and really, I don't know if you covered this last year, so we'll figure it out. I'm going to give you this compound, it's a totally blank screen, and part of what you have to do, I'll make this actually kind of tricky. Well, no, I won't. Okay. Part of what you have to do is figure out the charge on the transition metal. This one, you've got parentheses. You can recognize that as polyatomic ion. Cation is Fe. Boom, right there. Real up close and personal. Okay. So your iron is a transition metal. So you know it's iron. But you also know that if you just see that it's an iron ion, you do not know its charge. We need to write its charge. Write the charge. I'm going to flush that out a little bit. Write the positive charge of transition metals. Oh boy. Write the positive charge of transition metal ions as a Roman numeral. Okay, I'm going to make the prediction that we'll go over this in class a little bit today, and I will record that and post it also. But I don't know, you know, if you guys had a bunch of stuff like this in Chem A, but anyway, it's good. Okay. Yeah, okay, so wait, Write the positive charge of transition metal ions as a Roman numeral. Do we know the charge on the iron? Not yet. You're like, it's blank. How am I supposed to know its charge? Can we solve it? Can we figure it out? We know something about this iron. We know that this iron is stuck to 2 nitrates. oops, I just told you something. This iron is stuck to 2 NO3s. It's in parentheses. It's got that kind of circle shape going for it. It's 1 nitrogen and 3 oxygens. Here's your page of circle thingies. Find your nitrogens. Got some nitrogens up here. And you're looking for 1 nitrogen, 3 oxygens, because you've got NO3. Okay, so find the one with 1 nitrogen, 3 oxygens. Boopity boopity boop. Those are your options there. That's where we've got 1 nitrogen, 3 oxygens. And this page tells you all the things you want to know. It tells you 1 nitrogen and 3 oxygens has a charge of -1. It tells you that it's called a nitrate. It tells you its formula is NO3, and that charge is your key. The charge is -1. Take that back with you. You just figured out that NO3 has a charge of -1. You're like, yeah, duh. Okay, why does that help you? Why does it help you? How many nitrates do you have? You've got 2 nitrates. You've got a charge of -2 because you have 2 nitrates. How many iron ions do you have? 1 iron. And you know that this thing has got to be neutral. So you're going to write the sentence, something -1 -1. You know it's got to be neutral. That charge is, the net charge is going to equal 0. So the charge on the iron is, you can work it backwards if you want. 0 + 1 + 1 is 2. The iron has a charge of +2. And we figured it out because we were like, we know the compound is neutral. Well, the charge of the compound is neutral. We found the charge of the anion. And we used that to find, we can say we used math to find the charge of the metal. Of the transition metal. Whew. Oh boy, okay. We'll do another one like this too. You've got a transition metal. You use the charge of the anion to find the charge of the transition metal. Once you've got it, you're going to write the positive charge of the transition metal ion as a Roman numeral. Good. We found the charge of the transition metal ion. We know that that's an iron +2. When we write its name, there's its charge. We write it as a Roman numeral. So we found the charge on that iron. We're going to write it as that positive charge as a Roman numeral. Again, no idea how much depth you went to in anything last quarter. There's a chance you're like, duh, we've done this a billion times, and there's also a chance that you're like, whoa, we didn't look at this at all. Let me know on the call. We will take it from exactly where you are. just to finish this one, we found that charge. We said that this ion has charge of 2, and it's stuck to a nitrate. And that is our name. That's our formula. And that's our name. Let's do another transition metal. If this all made sense and you're like, yes, we crushed transition metal charges last quarter, you can skip the next example and skip to where I'm going to do names to formulas. I'm going to do one more formula to name just because. Why not? Okay. And here we're going to do ooh, yeah, I like it. Okay, we're going to do this. Oh, man. Okay, great. I'm going to show you a bunch of things in this one. Good. Okay. This one gives you the clue. Here's your polyatomic. It kind of looks like a circle. So your cation is your Cr. You may recognize that you don't see Cr all that often. So it might be in the C of the transition metals. You'll find I'll give you a hint. Most things that I use, especially if I'm coming up with this off the top of my head, will probably be in that top line. They're more common on Earth and just, we're more familiar with things like copper and zinc and whatever. Although sometimes they're in other places. Okay, so if it's not in the top line, keep looking. There's chromium. Boom. Right there. Just give you the name too. Okay, so we say it's chromium. But we also say chromium's in the sea of transition metals. We are going to need to write its positive charge in parentheses because it is transition metal. Great. Okay. We know it's positive. We know it's positive something. Use the same steps. We know the net charge of the compound is neutral. Find the charge of the anion. Your anion, you've got a phosphorus and 4 oxygens. Find your phosphorus stuff. You've got phosphorus and 4 oxygens. Phosphorus and 4 oxygens. That is a phosphate. PO4. Good. PO4. 3 minus. A charge of 3 minus. Your PO4, your phosphate. It's a charge of 3 minus. We've got 2 of them. Okay, this phosphate has 3 minus charges. Your second phosphate has 3 minus charges. How many minus charges altogether here? 6 minus charges. So how many plus charges must be on your chromium? 6. This is a plus 6 chromium. 5, 6. Okay. We only have 1 chromium ion, and it's got to carry, it gave away 6 electrons to those 2 phosphates because they each phosphate took 3 electrons. Okay. Sea of transition metals is weird because you can have things like a chromium with a charge of plus 6. They're really not attached to their electrons. Okay, so we figured out that chromium has a charge of 6 plus. And we'll just look at those steps again. We know that the compound, let's add compound. The compound charge is neutral. Net charge is neutral. We found the charge on the anion. We said that phosphate was -3. We're going to use math to find the charge on the transition metal. Here your transition metal is your chromium. It must have a charge of plus 6 to get those 6 negative charges to the phosphates. Okay. And your last step, write the positive charge of the transition metal ion as a Roman numeral. So we want to write 6 as a Roman numeral. 5 is V. 1 before 5 is 4, but 1 after 5 is 6. And there you got it. We took your formula. We found the charge of the anion. We used math to find the charge on the cation, that transition metal. And then we wrote the charge of the transition metal as a Roman numeral. Oh boy. Alright, we're almost done. Last part. So here's our chromium plus 6. Chromium 6, that's how you'd say it. If you're reading this name, you'd say chromium 6. And then the name of the anion, which we found was a phosphate. Alright, so next time you are hanging out in the lab, you can say to your friend, hey, I've got a bottle of chromium 6 phosphate. And that's what that would mean. That 6 is that chromium's got a charge of plus 6. Chromium 6 phosphate. I don't know what color this is off the top of my head, but I do know chromium, like the base root word inside of chromium is color. If you are an artist who works with color, there's a decent chance that some of your paints and your clays and your things, you know, ink may or may not use chromium, but paint may very well have a chromium ion as the color. And chromium is cool because depending on what you pair it with, it makes different visual colors to us. So chromium 6 is going to have a different color than a chromium 3 or chromium 2. And depending on like what you mush it with and its charge, you get chrome, you get different colors. Fun facts about it. Random stuff. Alright, so that is your formulas to names. Let's do some names to formulas. What if I give you, I'm going to make this one really hard, so if you get this one, you're also getting everything. Let's find another transition metal. Let's do nickel. Okay. Okay, so here I'm going to give you a name, and your task is to write the formula, and I do recognize that it's blurry. I wrote nickel 4 carbonate. Okay, good. I was going to have you figure that out. 1 before 5 is 4. Alright, off we go. We've got a nickel with a charge of 4 and a carbonate. Find your handy dandy. It ends in 8 right here. This, like I ate dinner. If it ends in 8, that's polyatomic. So you're looking for a polyatomic that has a carbon in the middle. Here's your clues. You've got a carbon 8. That is a polyatomic with a carbon in the middle. Good chance to figure that out, and whatever. Okay, I'm gonna keep this one. Okay, so here's your polyatomic with carbon in the middle. It's called carbonate. Check that A, make sure it's not an I. You are looking for carbonate. Cool, there's carbonate. It's got a formula CO3 2-. And we're just gonna copy that down. That is a CO3 with a charge of 2-. So steps. Find your, find the ions and charges, and then use math, so math it to make a neutral compound. Okay. Nickel's got a +4. Carbonate's got a -2. Is that neutral? No. +4 - 2 does not equal 0. But we have more negative. add another carbonate. Plus 4 minus 4, that's neutral. That equals 0. All right, and we've got 1 nickel plus 4, and we need 2 carbonates. Each carbonate is CO3, and we've got 2 of them. This got to be a very long video. Oh my gosh. Okay, so 1 nickel balances with 2 carbonates. That's your formula. Write that over here also. Nickel plus 4 will neutralize 2 carbonates, because each carbonate is -2. Let's do one with no Roman numeral. Back to the kind of friendly ions that you know exactly what they are. Let's do another aluminum. Aluminum hydroxide. The aluminum, from a few examples ago over here, that's in the +3 column. That whole column has a charge of +3. Aluminum +3. Hydroxide does not end in 8, but it is one word with like 2 elements in it. You've got some hydro part and some oxide part. That's probably got some hydrogen and some oxygen. Let's take your polyatomics. Find the one with some hydrogen and some oxygen. That's your hydroxide. It's OH minus 1. That's its formula, OH minus 1. You found the ions and their charges. You're going to math to write a neutral compound. Aluminum's +3. You probably see this one already. OH is -1. You need 3 OHs to neutralize the aluminum, and that is your formula. 1 aluminum neutralizes 3 OHs, and aluminum hydroxide has the formula AlOH3. Okay, cool. I'm going to stop this recording because this one got really long. Bring your questions to class and see you soon. And try out 5 on either side of the PDF for today. And we can look in that in class also. So there's going to be a link that says homework is PDF. Try 5 on the front and 5 on the back. See you soon.